Alright, had to make a third video here because 5 and 6 required me to pull up a calculator. Note that 140 degrees, not going to be on your unit circle, and neither is pi over 15. So nothing changes here in terms of the formulas we're using. X is r cosine theta, and y is r sine theta. That's going to be the same for both this guy on the left and the guy on the right. Unfortunately, sine theta and cosine theta for both of these is going to require either some calculator work or, a really interesting unit circle. You can probably find one. I'd rather use a calculator. So first thing, please make sure your calculator is in the mode you want. Since that first one is in degrees, we can go Doc, Settings, Document Settings, and make sure that we are in degrees. Note that I am not. So I'm going to change it so that my calculator is in degrees. And I want R, which was 9, cosine of theta. My theta is in the lower left-hand corner here. But of course, theta is 140, duh. So I want R cosine of theta. Thanks, calculator, I appreciate you. That'll give me negative 6.894. The instructions here say round to the nearest hundredth, so 2 decimal places, that would be negative 6.89. And then I also want r sine theta. So 5.79. Then doing the same thing, but now with a radian value, that pi over 15. Again, just kind of reminding you that you can flip-flop your calculator between modes here. Under the doc menu, settings and status, document settings. Now I want to go back to radians. And then we can do the same thing. Go ahead and clear the screen. Clear. Negative 3.5, again, our cosine theta. This will get me my x value. Cosine, now theta is going to be pi over 15. Which gives me negative 3.42, and then r sine of theta. So many buttons, success. So again, don't worry if you have to jump to a calculator for some of these problems. Your calculator is perfectly willing to deal with ugly fractions and things that are not on the unit circle. So there you have this one. And the nice thing about a calculator is when you suddenly recognize that a number looks really big, you can go back and input that extra decimal point. Yes, much nicer. So there we have it, our x value and our y value. Ignore this guy. Success. So at this point, what we have done is taken a look at 6 examples converting from polar coordinates to rectangular coordinates. We also want to be comfortable going the other way, going from rectangular to polar. So we will put those in a separate set of videos.